All right, so what's normalizing a vector? It means if you're given a vector, you divide it by its own size. So that this new vector has size what? What's the magnitude of this new vector? Okay. So my point is that if you have a vector and if you divide the vector by its size, its magnitude, then this new vector is going to have size 1. This will have magnitude 1. And we denote it by putting a head on top. Such a vector is called?
Unit vector.
A unit vector, very good. Okay. That's a unit vector. Now, unit vectors are important because you remember that the dot product is defined as the norm of each multiplied, and you multiply by the cosine between. Now, if the second one is a unit vector, then because this is size 1, this is just simply going to get norm of u times cosine theta. Now, in terms of a picture, this is what's going on. So let's say here's u, here's v, and let's say here's this much is v resized to size 1. Okay. Then if you make this right triangle, and if you want to know this length, which is known as the component of u in v's direction, okay? That is going to be acquired by taking this length times the cosine of the angle between. Just by using SOHCAHTOA, you know that this length times cosine theta gives you this length. Okay? That's what's known as the component. Okay? And here's my point. My point is that you probably have seen this formula before. This is the formula for component of u in the direction of v. Okay. And my point is that people have different level of understanding when it comes to math. Some of you are just going to take this as a formula, write it several times, and memorize it, and that's it, okay? And that's not going to really help you much because a few days later, you're going to forget it, okay? Now, other people will be who have a better understanding of this can write this in this way. You can write it as u dotted with v hat over norm of v. Right? Same thing, right? Because if you do u dot, it's same thing as just dotting it on the top, right? But if you write it this way, what is this part? It's a unit vector. Now, taking a vector and doing a dot product with a unit vector gives you the component in that direction. That's what we observe, right? So once you have that understanding and you look at this formula in that way, then it just makes sense. Okay? So that improves your not only it improves your understanding, but anytime you have to come up with this formula, you're not just reciting this, rather you're thinking, oh, I have a vector and I have a unit vector in that direction. If I do the dot product, I will pick up that component in the v's direction. That's what's happening. Okay? And you should also pay attention to the way I say this. I want to know the component of the vector u in the direction of v. Yeah. You should see, a lot of times when you see a formula, you just recite the formula many times without really thinking about what's what, right? Because this is not symmetric, right? Why do I put v on the denominator and not the u? And that's because you're putting the v under, so that's a tactic to make sure that you remember it correctly. But not only that, you're taking the vector u in the direction of v. That's the meaning of this, okay? Now, what about projection? Well, before we do the projection, Here's a find a vector of length or magnitude 3 in the direction of v. Now, how do you do that? You take v divided by its size. This has size 1. So how do you make this size 3? Times by 3, right? So that's the simple answer. So a second reason why you want to know normalizing a vector is it makes it easy for you to construct a vector of a given size in the direction of v. Because you can just first divide by its size to make a unit vector and you just multiply, okay? So here's the formula for the projection of vector u over v, which if you look at the textbook, they write it like this. And you walk into the exam thinking, okay, I have that memorized, so I'm all set. But then the moment when you try to apply it, you just forget what it was, right? You think you remember because I say this all the time, but a lot of you overestimate your ability to memorize and underestimate your ability to reason. Yeah. Because actually you're smarter than you think. You can actually reason things, and you're actually very bad at remembering things. I mean, this looks only slightly more complicated this, and it might not be too much of a ask to memorize this right before the exam, you think, but that's not a good idea. The better thing to do is to rewrite that in the following way. You want to rewrite this as u dot v over norm of v, and this much is a component, and you multiply this. Okay. Now, if you write it this way, then look at what this is saying. I need a vector whose length is same as the component, right? But in the direction of v. That's why I need it. So this structure is exactly the same as this one, right? Same thing over here. Instead of 3, I just have this. You get that? Yeah. And that's what I mean by having a deeper understanding. Once this clicks, you will never forget the formula for projection. Yeah. I mean, maybe you might wonder, like, what do I do to prepare my class? I just walk in here without any notes, right? And you might ask, do I take a peek at the projection formula before I come in? And the answer is no. I just prove it right on the spot. This is what goes in my head. The first one tells me, oh, this picks up the component. And then after that, I just have to construct the vector in that unit vector. Once you have all the formulas in this way, there's nothing to memorize. It's just obvious.